Today we're going to be talking about adding rational expressions, but before we can do that, we need to talk about how we actually add fractions in general. So if we have something like 1/4 plus 5/6, and we're working on adding these two fractions together, we do need to get a common denominator. So if we have 4 and 6, the least common multiple between those would be 12. So our common denominator is going to be 12. You could also use 24, but then that means that your numbers are going to be bigger and you're going to have to simplify. So I would strongly suggest that you're trying to find the least common multiple between your denominators. Okay, so if our common denominator is 12, then what we need to do is figure out how we've gone from the old denominator 4 to the new denominator 12. So that means that we're going to multiply the denominator and the numerator by 3. So 3 times 1 would give us 3. Okay, so 1/4 is the same thing as 3/12. To get from 6 to 12, we need to multiply this fraction by 2 over 2, because remember that's just the same thing as multiplying by 1. So that would give us 10/12. And then with this, we're going to add the numerator pieces. So 3 plus 10 is 13. And then we're going to keep that over 12. And that can't be simplified at all. So that would be our answer. Okay. Now, the biggest mistake that people make is trying to reduce too early. So if you're trying to reduce further back here by dividing all of those by 2, this by 3 and then these by 2, you're going to get back to the original question, which isn't going to help us at all. So you're going to wait to reduce until the very, very end of your question. All right. So let's look at our steps for adding rational expressions. So we're going to factor the denominators if necessary. Then we're going to find the common denominator. So we're going to work through that process here. We're going to multiply the numerator and denominator to create the common denominator, just like we just did in this basic numerical example. Step 4 is to distribute and combine like terms in the numerator. That's all we're doing. We took that 3 and that 10 in the example prior here, and we added those together. But we're going to keep the denominator the same. And then the last thing is to check and see if the numerator will factor to cancel with the denominator. Okay? So let's take a look at what this would actually look like. If I can get the example up here for us. All right, so first example we have 5y plus 2 divided by xy squared plus 3x minus 6 divided by 4xy. So the first thing we have to do is figure out our common denominator. Okay, so we're looking here, our common denominator, remember, should be the least common multiple. So it's the smallest number that they have in common and then the smallest variables that they have in common when they're monomials. So we know we need to use 4 because this fraction has a 4. They both already share one x in common, so I just need one x. Here we have y squared and here we have y, so we do need y squared to be our common denominator. So what do we need in order to go from the original denominator to the new? So we're missing the 4, so we definitely need to multiply by 4 to both the numerator and the denominator. We have the x and we have the y squared. So when we multiply this 4 to the numerator, we do need to distribute in. That means we would get 20y plus 8. Okay? To go from the second fraction's denominator to the new denominator, we already have the 4, we have the x, we have one y, but we need another one, so we're going to multiply both the numerator and the denominator by y. So again, we're going to distribute in. So that means that we would have 3xy minus 6y. Okay? And that's all over this common denominator of 4xy squared. Next thing is to combine like terms, whatever that means, in the numerator. So 20y minus 6y gives us 14y. The 8 and then the 3xy don't have anything to combine with. We still have our common denominator of 4xy squared. And then we're looking here, there's nothing that the numerator has in common. There's no GCF, and there's nothing to do in the denominator there at all. They all don't have a number in common either, which means that this is our answer. Okay, that's the sum, the answer to that addition question. And then we do also need restrictions. So with adding fractions, our restrictions are only going to come from the denominator. So since it's a monomial, we would have x can't equal 0 and y can't equal 0 as our two restrictions. Okay, so let's take it to the next step here. If we have 2 divided by x squared plus 7x plus 10 plus 4x divided by 3x plus 15, the first thing we need to do here is factor the denominators. So we need x and x here, obviously. We need two numbers that multiply to give us 10 and add to give us 7. Those numbers would be positive 5 and positive 2. In the second fraction, the only thing we can do there is take out a GCF of 3. So now when we go to build our common denominator, we need to choose everything that they already have in common. So they both already have an x plus 5. And you can also put little checks to make sure you're taking care of everything. I have an x plus 2 that the first fraction has. And then the second fraction has a 3 that I haven't used. So I've used all of the different pieces to create my common denominator. Again, you're looking for what they have in common first and then going in to whatever else is left. All right, so the first fraction, it has the x plus 5 and it has the x plus 2. It's missing the 3. So we need to multiply that to both pieces, which means that we're going to end up with 6. The second fraction has the 3, has the x plus 5, but it's missing the x plus 2. So we're going to distribute that in and get 4x squared plus 8x. So then we're going to write this in standard form on the numerator. So we have 4x squared plus 8x plus 6 over our common denominator of 3 times the quantity x plus 5 times the quantity x plus 2. Now, I notice here in the numerator that they're all divisible by 2. So if I take that GCF of 2 out, we would have left inside 2x squared plus 4x plus 3. And then we still have our common denominator. Now this 2x squared plus 4x plus 3 doesn't factor at all. So taking that 2 out is fine. You can leave this as your answer here. You would also get full credit here because when you take the GCF out, it doesn't make anything cancel with the denominator. Either of these would be acceptable answers. Okay, you still need to check for it taking out the GCF, but if you notice in doing that work it's not going to make anything cross off, then it's okay to leave it here. We do also need our restrictions. So the GCF of 3, this here doesn't have any restrictions. We would get x can equal negative 5, and then x can equal negative 2. Okay, let's look at one more here. We have 5x divided by x squared minus x minus 6 plus 4 divided by x squared plus 4x plus 4. We're adding, so we're going to factor the denominators. Here we need x and x, and then we need two numbers that multiply to give us negative 6 and add to give us a negative 1. So that would be a negative 3 and a positive 2. And then x squared plus 4x plus 4. We know we need x and x, and two numbers that multiply to give us 4 and add to give us 4 would be a positive 2 and a positive 2. So now we're going to build our common denominator here. So we're looking what they already have in common. Here we have an x plus 2 that they share in common. Then we have an x minus 3. and another x plus 2. So you can choose to put that x plus 2 wherever you want, okay? But here we have to use 2 x plus 2's in our common denominator since this fraction had 2 and this one only had 1. They only share 1 in common, so we have to make sure that we're taking everything else that's left, even if it's something that we've already used, okay? So first fraction, we have x minus 3 and x plus 2. That means we need another x plus 2 to multiply this. So that would give us 5x squared plus 10x. The second fraction has 2x plus 2, so it's missing the x minus 3. And that would give us 4x minus 12 when we distribute in. So then we're going to combine like terms in the numerator. So 5x squared, the x's in the middle, combined to give us 14x, and we have our minus 12. And then for our common denominator here, since it's x plus 2 twice, you can clean it up and write it as x plus 2 squared. You can also leave it as x plus 2 and be perfectly fine. So the denominator stays the same. Here we're looking to see if the numerator will factor, but there's nothing that we can do to make that factor. So here is our answer. And then the last part of this is to find our restrictions. And remember, you're only looking in the denominator for this. So we would have x can equal -2 and x can equal a positive 3. And that's it. So one thing that you're going to want to make sure you're really careful with is that you're finding a common denominator. You're also going to make sure that you're only distributing and combining like terms in the numerator. You will never multiply this denominator back together again. And finally, looking at these answers compared to what we've seen in the past, these aren't very pretty. They're ugly looking answers, and that's okay. Just make sure you take your time. There's lots of different steps in this process. And finally, writing your restrictions. Okay, that's it.